investigating quadratic graphs. Now, the first 4 steps, I'm going to simplify them for you, and I'm going to use Desmos instead of GeoGebra, but if you would prefer to follow these steps, that's absolutely fine. You're going to go on to Desmos Quadratics. Once we've got open Desmos Quadratics, we can see that our equation is going to be y equals x squared plus bx plus c. And the best one to press is graphing a quadratic equation. Now, here it says y equals x squared plus bx plus c. Have a think about what we need to remove, which letter from here in order to make this the same. The first step, it says to move the sliders b and c until the quadratic graph crosses the axes at 2 integer values. So we're going to move b and we're going to move c. And you can see it's not crossing at an integer value, but you need to continue moving this until it crosses at an exact number. Normally what would be helpful is to type exact numbers in here, and that's more likely to give you an exact number where it crosses. If it's taking you too long to do this, think about an equation that easily factorizes, and therefore that's going to give you a nice solution here. It says to write down the 2 x-axis crossings and also the y-axis. So what you do is you'd click the numbers here, write these 2 down, but make sure they're whole numbers and then see where it crosses on the y-axis. We're going to repeat this process. Then, once we've found a rule, we're going to state the rule. So maybe you're going to think about, what are the rules for factorising quadratics? Does it link with a graph? Once you've stated the rule, verify means to do the problem once more with another value to see if it works for the quadratic. And then finally, see if the rule works if the numbers are not integers. Then if you scroll to the bottom, it says that to get a level 3 or 4, you're going to clearly state one rule. Now, for non-monic quadratics, this is when we have a non-value of 1 in front of x squared, so it's not going to be 1. So we need to make sure a this time is not 1, so we're going to change this about. We're going to repeat the whole process again and check our rules. Another rule you can think about for this section, for example, is completing the square. Or you could think about the quadratic formula. What in the quadratic formula causes the graph to have 2 x-intercepts? And then last but not least, you have to do it with this equation. So I would copy this equation and try and paste it. If it doesn't work, I will show you how to type it. You just need to do a plus b and then a dash, and then it automatically creates a fraction for you. Press enter, and this is our function. And we've got a few more questions here to finish up. In this investigation, what you need to think about is what we've gone over with a quadratic graph, the rules you might be alluding to could be linking to anything to do with the quadratic graph that we've learned this last few lessons. For example, the vertex can be found using the axes of symmetry formula, minus b over 2a, whereas the x-intercepts, they can be found by factorising, quadratic formula, or completing the square. And the vertex could also be found by completing the square but not solving it. And the y-intercept is always quite obvious. So those are the kind of things you're going to have to refer to during your investigation. Good luck.